Welcome to Dynatech's Master Data Management Platform. In this demo, we will walk through data quality validation, the common data model, match and merge, and address validation capabilities that help deliver clean, trusted, and business-ready master data. Dynatech's Master Data Management System provides a centralized environment to manage master data, apply validation rules, and monitor data quality through an interactive dashboard. Users can log in using a username and password or authenticate directly through Microsoft Azure AD. Upon login, the system opens the main data quality dashboard, giving an overview of validation activity, configured rules, and quality metrics. From the navigation panel, user can navigate to the Data Quality Rules section. The Data Quality Rules section displays all available validation rules. These rules originate from the Great Expectations library and include clear descriptions for business understanding. Custom rules can be created directly from the interface when generic rules are insufficient. Simply click on New Rule, add the rule, and click on the Submit button. New rules are added instantly and become available for assignment. Click on the Enable Data Quality tab from the navigation panel. It lists all tables across Fabric workspaces: database, table name, description, type, suggested name source system, modified by, status, selected, and action. Users can select the tables they want to validate and submit suggestions for approval. A governance workflow ensures that validations are approved by a senior data engineer before execution. Azure OpenAI enriches table metadata by generating descriptions, table types, and recommended business-friendly names. For instance, here the user wants to see the description for contact. The user can simply expand and see the entire description. This is particularly useful for complex ERP systems such as SAP or NetSuite, where technical names are not intuitive for business teams. The user can also provide the suggested table name and click on the Submit button. New tables from any connected source system can be added easily. Once added, metadata fields are automatically populated through AI analysis. Once submitted, the table is added to the list. Next, click on the Data Quality Rule Summary from the navigation panel. The Run History section displays all previous validation runs, including workspace, database, source system, table name, run ID, status, and run timestamp. This provides full traceability for audits and debugging. Next, click on the Data Quality Rule Details. At the column level, the system shows AI-generated Suggested Column and Recommended Validation Rules. Regex conditions, AI reasoning, acceptable ranges, and pattern checks are automatically suggested based on data analysis. This eliminates the need for manual scripting. All rules run automatically once validations are triggered. Users can track the validation from the Run ID logs, created by, and so on. Records that fail validation are routed to audit tables for review and correction. The Data Quality Dashboard gives a consolidated view of pass-fail records, overall quality percentage, and rule-wise performance. Here, there are two source systems, D365 and SAP. Users can view into source systems, tables, and columns to identify areas requiring improvement. Click on the failed records to view complete details such as the data quality percentage, pass-fail counts, and table-wise breakdowns. This helps teams quickly identify where issues originate and improve data accuracy at the source, ensuring cleaner and more reliable data for all downstream processes. In the MDM tool, the CDM capability allows organizations to standardize data coming from multiple databases and tables by creating a unified common data model structure. Here, we are viewing an example of a CDM model. This model represents the vendor master. The workspace, database layer, and table representing the target storage location are all visible. To create a new CDM model, click on Plus Create. Users can specify the model name, the workspace, the database layer such as Silver, and the table name such as Vendor Master. If the target entity does not already exist, the system allows creation of a new table directly from the interface. Next, the users can click on the Submit button. After submission, the CDM model is created and stored with its corresponding metadata, including timestamps. Once the CDM model is created, users can view the fields of the target table, such as created date, vendor ID, vendor name, vendor type, and related properties. Mapping enables consolidation of multiple source systems into a single standardized target table. By selecting View, we can prepare mappings for the CDM model. For example, vendor data may originate from 3 different systems: NetSuite, F&O, and CRM. The mapping screen displays all available mappings and allows configuration for each source. Users can select the source system, choose the relevant source table, and link it to the CDM model created earlier. Source and target fields are displayed side by side. Users can map each source field to the appropriate target field defined in the CDM model. Once submitted, the mapping is stored. The process can be repeated for all source systems, F&O, NetSuite, and CRM, to ensure each system's data is aligned to the same standardized format. After all mappings are created, data from all connected systems is consolidated and loaded into the vendor master table defined in the CDM model. The same approach applies to customer master. CDM models and mappings can be configured to consolidate customer data from multiple systems. In the MDM tool, the Match and Merge functionality enables organizations to identify duplicate or similar records across multiple tables and merge them into a single, accurate master record. In this example, the user is comparing sales rep and employee tables. The system calculates a match score between fields such as sales rep name and employee name, helping identify which records likely represent the same individual. To begin, a new purpose is created. For example, Sales Rep Match and Merge. Users can select the workspace, database, and the source system containing the relevant tables and click on the Submit button. After submission, the system creates the Match and Merge configuration, allowing users to proceed with mapping and processing. If any configuration is not required, it can be removed from the list. The next step is selecting the primary table, which is usually the system considered the primary source of truth. In this example, the sales rep table is selected. Users can then select one or more secondary tables. Users can also select databases. Here, the user is selecting the employee table to compare against the primary table. Multiple tables can be selected when matching across several systems. Next, users map the fields used for calculating match scores, including match indicators and primary key indicators. These drive the matching logic between the selected tables. Once the mapping is complete, the system prompts for the workspace, database, and target table, where the cleaned and merged data will be stored. After validation, the merged or matched records are written into the designated table created during configuration. In the Match and Merge process screen, source records from the primary and secondary tables are displayed, along with the calculated match scores. Statuses such as suggested, submitted, and approved help track progress. Match scores, such as 52, 58, or 92, indicate the confidence level of the match. Higher scores suggest a stronger match. These scores are generated using Python-based matching logic. Users can review suggested matches, select the correct ones, and submit them for approval. Once submitted, records go through an approval workflow. Approved records are merged into the master table, and previously approved matches are locked to prevent duplicate processing. Approved matches are reflected in the master table. Submitted records await manager approval. Match statuses update automatically as records progress through the workflow. In the MDM tool, address validation enables verification and correction of address fields using external validation APIs. To configure address validation, users create a new configuration and assign a gateway name, selecting the API they wish to use, such as EasyBoost, Melissa, or Google. Users can provide API key, endpoint URL, and the request-response fields that need to be validated. These details define how the Address Validation API will communicate with the MDM system. After submission, the configuration is stored with details including gateway name, endpoint, request body, response body, and API key. Users can view, modify, or delete existing configurations. Next, users can create a configuration mapping by selecting the source table and mapping it to the API configuration. For example, the customer address table can be selected for validation. In the mapping options, users can view the source table data, merged results, or delete the mapping if required. After selecting the source table, the system displays address-related fields for mapping. This ensures that the required address columns are used for validation. The fields defined in the API request body are mapped to fields in the source table. Primary or secondary key identification is also selected during this step. Once submitted, the mapping is saved, and the system generates the source data for validation. Source records appear with statuses such as suggested, submitted, or approved. Approved records are locked, while submitted records await manager approval. Users can view suggested corrections, such as revised street names or address components. Suggested values can be accepted by selecting them and submitting for merge. All approved and validated address records appear in the master table. Thank you for watching.